Okay, you can start by solving some questions. So this week we'll be solving some questions on dining philosopher problem. So in last class also we have seen some examples of the critical sections and all, and we have seen that where deadlock happened. So the concept will be covered today is about system model, deadlock prevention, deadlock avoidance, deadlock detection, recovery from deadlocks, and all. Okay. So from the uh, uh, tutorial from the NPTEL website, you have already seen about this algorithm, which is called the banker's algorithm. Okay. So you can solve the question. You can try to solve the question. So I will definitely try from my side also that to make you understand how these process are going. হ্যাঁ হ্যালো হ্যালো হ্যাঁ করেছিলাম, আমার ফোন ধরেনি বুঝলি তো, আমি আর একবার করে তারপর দেখছি। আমি করেছিলাম, ধরেনি। হুম। ও আচ্ছা, ওয়েট করছিল। ও সরি সরি সরি। হুম আমার আমার ওই ক্লাস শুরু হয়ে গেছে না, ওই জন্য আমি করছিলাম, মেসেজ করেছি। হুম হুম। আমি বলে দেবো আজকে রাতের মধ্যে। হ্যাঁ আমি জানিয়ে দেবো, সে কল ব্যাক করলে উঠিয়ে নেবো, অসুবিধা নেই। ঠিক আছে, বাই। না আমি করছি। Hi. So we'll start from the first thing first. That is, we'll try to see what are the necessary conditions for the deadlocks and how deadlock happens basically. Okay. So I assume that you know each of these terms, like what is mutual exclusion, what is hold and wait, what is preemption mean, because we have already seen this terminology earlier tutorials in the earlier tutorials. Okay. So mutual exclusion is that they should not allow multiple process for a single resource. Okay. And no preemption means that why some process is using some process, you can, while some process is using some resources, you can't take the same resources. Okay. So a deadlock means that it is a set of process, or it is said to be a set of processes are said to be in deadlock if they wait for, or if they wait for an event caused by others in same set. Okay, so suppose you are using a washroom, and some of your colleagues are also waiting for the same washroom, and but you are not coming back from there. So that's the deadlock situation. Okay, so when you go to a washroom, so you go, you use that, and you come out. So this process that there is a long wait. Okay, of course, you are waiting for your colleagues are waiting for a very long time, or you are waiting for someone for a very long time. So this is called starvation. Okay, starvation means long wait, and deadlock means that, so there is a difference that you are waiting for something, so you can wait for a long time. That is called starvation. But if you wait for infinite time, then it called that it is a deadlock. Okay, so this is the scenario. So first we will see something that we will see an example that suppose a system is having three user process. Okay, so where each of the process require two unit of resource. Oh, okay, maybe you can denote it as R. Okay, so you want to find out the minimum number of, you want to find out the minimum number of units of R such that no deadlock occur. Okay, the question is clear that you have three user process. Okay, and each process require two unit of resource. Okay, the minimum number of unit required such that no deadlock occur. Can you answer the question and write in the chat box? Suppose you had, how you will solve this, you have P1, P2, P3, three user process I have mentioned. Okay, and we have resources, number of resources. Okay, so what is the minimum number of units of R required to finish the process such that no deadlock will occur? So suppose we can start from, so suppose we have one resource. Okay, will there be a deadlock? Yes, because if you have one resource, if any process want to execute, it needs minimum two unit of resource. So one is not a possible option. Okay, fine. Now, if you have two resources, then suppose one is taken by this process P1, okay, and one is taken by this process P2. Okay, now will there be a deadlock? Yes, because P1 will be waiting for one resource, P2 will be waiting for one resource. Okay, but you have only two resources and you have allocated all of them. So there will be a deadlock situation. Okay, now if you have three resources, now see this carefully. P1 take 3, P2 take 3, P1 take 1. Okay, now you altogether have three resources, but to finish at least one process, you need two unit of resources. Okay, two unit of resources. So this is also a deadlock. This cannot be done. Okay, if you have four number of resources, then at least one of them you can allocate two resource, and it will finish, then it will release the resource, then it will execute, then it can execute. So at least four resources are required to execute this kind of these three user process. So I hope that this definition is clear, that how the what is the minimum number of processes required to finish the process. Fine. Now we can extend this idea that like we have P1 to P2 to Pn number of processes, and X1 to X2 to Xn. Okay, Xn, so Xn be the number of, this hash means number of resources one process needs to finish its execution. Are you getting my idea? Like that, here we have stated that each process need two resources. Okay, but this is not the same scenario. Will not be, this scenario will not be same for the each and every case, because uh, this will not be possible that each process will require two resources only. So multiple processes have multiple requirements. So that's why I have stated here that if P1 processes need X1 resource, P2 process need X2 resource, and Pn process need Xn resource. So these are variable. So in this scenario, find out the maximum number of resources which will cause a deadlock. So see the question here. Question is find the maximum number of resources which will cause a deadlock. Maximum number of resources. But in the previous question, we questioned about minimum number of resources we require such that no deadlock occur. So our answer was 4. That if I have 4 process, then this is the minimum. 4 was the minimum number of resource needed such that no deadlock will occur. But what is the maximum number of process, maximum number of resource which will cause deadlock? That if I have three resource, 3 is the maximum number of resource which will cause a deadlock. Okay, so that means that 1 will cause a deadlock definitely. 2 will also cause a deadlock. 3 is the maximum. 3 is the upper bound that of, if you get 3 resources also, the all process will not be executed. Okay, so 3 is the maximum that there will be a deadlock, and 4 is the minimum that there will not be a deadlock. Are you getting the points? So this is the question now, that what is the maximum number of resources which will cause a deadlock. Can anyone give answer of this? You can write your answer in the chat box. Can we allocate two resources to P1 in previous question? Okay, if you write, so if you write, it, yes, you are saying that you will be allocating two resources to P1, then it will execute, then P2 will execute, then P2 will also finish, then P3 will come into the picture. Yeah, this was your question, right? So this you can do. but but the thing is that we have three user process. So in user process where you have two resources, uh, then it will be shared, like number of resources will be shared among, like, because each one of, there is in the question there is nothing called the priority, so you can assume that all are with same priority. Okay, so p1 is also waiting, p2 is also waiting, and p3 is also waiting. So whenever all are waiting, so if you have something to give them away, so you will, at least whatever in your hand, you will give one of, at least one of the resources to them. Okay, then you can otherwise you have to mention that p1 has a highest priority, give them two, then come to p2. Okay, that wasn't mentioned in the question. So in this scenario, what we'll do, that if this is the case, that p1 p2 to pn, if you have this number of processes, then you can give x1 minus 1 resources to p1, x1 minus 1, x2 minus 2 resources to p2, and xn minus 1 resources to pn. Okay, so you will assign all the resources to every process except one. Oh, okay, so if you have total sigma I is equal to 1 to n xi minus n resource, then there will be a deadlock. Okay, so what I am trying to do here, if I have at least, if I have sigma xi minus n plus 1, if I have at least one extra, then I will, I, this minus 1 will not be here, so p1 will have x1 resource and p2 will be executed, and our work will be done. So there will not be any deadlock. But what we want a deadlock situation. So that's why we will give all the resources except one. So this is the number where there this is the maximum number of resources. If you give it, also there will be deadlock, and this is the minimum, that no deadlock. Okay, I hope you understood what I understood. Okay, so if you want to see an example of this, I can say that. So you have P1 process, P2 process, P3 process, three process. So so suppose you need two resource for P1, three resource for P2, and four resource for P4 to finish its execution. Okay. Then if you give P1 to 1, P2 to 2, and P 3. So this is the maximum. So this 6 is the maximum that there will be a deadlock. And 7 is the minimum. 7 is the minimum that there will not be a deadlock. Okay, fine. Mm, now, okay. Now a question arises that you have total 100 resources and pi is equal to 2. 2. Okay, so that means that each process will require two resources to finish its execution. Now question is, find out number of processes. Are you getting my question? Please answer this question and write in the chat. So can anyone try to answer this question and write the answer in chat? No, not 51. So you have you have R is equal to 100 resources. So you need to your goal is to find this number of I. What is I? Okay. So you see that if you have P1 to P2 to P100, then you give one resource to everyone. Okay. Okay. Then so here you have seen that every resource you give x1 minus 1, x2 minus 1, xn minus 1. So in the same scenario, I am giving, because each required 2, I am giving 1 to each and every one. Like x1 means 2 minus 1, x2 means 2 minus 1. Okay, so that is like x1 minus 1, x2 minus 1, xn minus 1. Now in this scenario, there will be a deadlock. This is a deadlock scenario. But if you just remove one process, that means P99, and you have one resource extra. So you can give this one resource to P99, it can execute, and it your process will be free. Then P2 can execute. Then P98 execute, 97 execute, P96 execute, and everyone can execute. So answer is 99. Okay. Now another question is, suppose you have n processes. P1 to Pn. Okay, which share m identical resource. Okay. So if I give some options like for when si less than m, there is a sigma also as you want to one. Read the question, understand what I want to say, then answer it. Okay, so uh, like no one has answered, so I'm saying that your total resources was R is equal to M. Okay, and P Pi is equal to Si. That you have n processes. So you have seen this earlier that which required s number of process, Si number of process. So if you give this Sn minus 1, then there will not there. So what is the maximum number of m so that there is a deadlock? So that is sigma s si. So you can find out like this, that if m less than is equal to sigma I is equal to 1 to n si minus n. So if this is the case, then there will be a deadlock. Fine. Now what is your question? That your question is, which one of the following is sufficient for ensuring deadlock will not occur? Now try this out. Hello. হুম। আরে ওই যে ডিরেক্টর আছে না, যে তোদের যে ডিরেক্টর আছে বোধহয়, সে কি হার্টের? আমি তো নাম এক্স্যাক্টলি জানি না, মানে যে, ও আচ্ছা। আহ, আমি যতদূর জানতাম যে ওই যে ডিরেক্টর। So where were we? So this was the thing that if there will be a deadlock if this was the case. Otherwise, if sigma I is equal to 1 to n, si less than n plus n, so this will be the minimum number of cases that were which ensures that deadlock will not occur. Okay. Now there is something that we want to develop something for the deadlock algorithm. So deadlock prevention algorithm basically. So deadlock prevention means that so there are some condition for the deadlock prevention, that condition, and there are some approach, that is mutual exclusion, hold and wait. যেতে বলেছে হ্যাঁ হ্যাঁ ও বলে দিয়েছে যে টাকা টাইটেল ওনার মনেই আছে আমি বলে দিয়েছি ওকে একবার যে কথা বলতে চাই আগে কন্ট্যাক্ট করেছিল তো সেরকম বললেই হয়ে যাবে আর কি যে ডক্টর ওরকম রনিতের আর কি এর থেকে এসছে তো এরকম বললেই ও দেখা করবে অসুবিধা নেই ঠিক আছে ঠিক আছে না যেতে বলিস কাউকে হ্যাঁ so there are something will be given which is called E. So we'll denote E as total number of resources, some allocated resources, and some available resources. Okay. So now we have to find that what is the safe state. Okay. So so how this will be given? That you will be given a process. So we have some already allocated. Now we will be knowing the maximum need and we'll be knowing the future need. Okay. So A, B, C, D, 1, 0, 2, 1, 1, 2, 0, 1, 1, 0, 0, 1, 1, 1, 2, 0, 0, 0, 2, 1, 2, 1, 2, 0. Okay, so you have to find the future need first. Okay, so now within the question, it will be given that this is available available is equal to 0 0 x 1 1. Now you have to find the smallest value of x of which this is a steady state. Okay, so suppose your future is given like 0 1 0 0 2, 0 2 1 0 0, 1 0 3 0 0, 0 0 1 1 0. Okay, so here, so you have total resources, total allocated, total available, and you know the future. Uh, so basically, you have to find this out, that what is the future need. Okay, so I am also giving this, but I am not in this scenario. I am not giving you the total available list. So this is the total available. So here main thing is that x is not given. Okay, so you have to find this x. Okay, so how we will approach that, a necessary condition for deadlock is at least one need should be satisfied by available resources. So here it will, like, so at least one need should be satisfied. Okay, so what you will do, that we'll put at least one need, at least x is equal to 1, then it can, if x is equal to 1, then it can satisfy the need of resource d. You can see that for resource, for here, 1 1 1 1 1 1 1 2 2 0. Okay, this is the maximum need. Okay, so what is the future need? That future need is 0 0. So if you put 1 here, okay, so you can see like this, that need of d is 0 0 1 1 0, and a is available is 0 0 1 1 1. How I am saying this, that I have put x is equal to 1 here. Okay, x is equal to 1 here. Okay, so is it less than or greater than? So available is greater than the need. Then now, so allocated for a is 0 0 1 1 1, and what is the new available? 1 1 1 1 0, which is 1 2 2 1 1. Okay, but this new available, so this new available, so are you getting my point, that if you give at least one, then it will satisfy the need of d. So d is finished. Okay, fine. Now what is the new available? The new available is the, you will add, so this resource is free, these resources will be free, and whatever you have, you allocated, this will be free, you add these two. Okay, I am adding from here and from here. Are you getting my point? So this is the new available. New available. Okay, now with this new available, can I satisfy anyone from this? So this is the question. Okay, so this cannot satisfy anyone from this maximum need. So what I can do, that I can put x is equal to 2. So if x is equal to 2, then we will start from the beginning. Available resource is 0 0 2 1 1. So I am putting x is equal to 2 here. Okay, so allocated for a is 0, that is new available is 1 1 0 2 1. Okay, now this will satisfy c, then need of c is 1 0 3 0 0. You can see from here. need of C is 21311. That is future need is 10300, which is less than new available. That is 11321. Okay. So we find a set sequence that if you, what is a set sequence? Set sequence is you D C B A. Okay. So first you run D, then C, then B, then A with x is equal to 2. Okay, got it? So this is the scenario. Now try to solve this question. So this is the banker algorithm. Now the banker algorithm is used to detect the deadlock in the system. Only works for a single process system. Is an approach to prevent deadlock. Requires knowledge for current resource allocation of processes. Is primary use for memory management in the operating system. So which one from this is the true? So in banker's algorithm requires knowledge of the current resource allocation of the process. This is the correct answer. Okay, because you have seen from here, you need the current allocation. You need the resource of the current allocation. Now can you solve this one? What will be the safe sequence? So here first see that what is available. Available that 15 of class A, 10, 12, and 7. Okay, this is available and this is your current allocation. This is your maximum demand. So what we can do, the future need. What is the future need? Future need is just minus it. Okay. So the first step one. So step one is to find the future need. Okay. I will do that. We will do just 8 minus 3, 5, 5, 4 minus 2, 2, 6 minus 2, 4, 3 minus 1, 2. Then 6 minus 2, 4, 2 minus 1, 1, 3 minus 1, 2, 2 minus 2, 0, 6, 2, 4, 3, 1, 1, 0. So this is the future need. Okay. Now what is the safe sequence? So you can see that the all the future need is less than the available. Okay, so this system is in safe state. Okay, so you can run in any order like P1, P2, P3, P4, any order. Okay, so this is the correct answer. Fine. Now the next question is, yes, B is the correct answer. T-thread mutex is used to prevent race condition and ensure that only one thread can access the critical section at a time. Okay. Yes, P-thread mutex lock. So this is the case that if you have a single instance and single instance, what is a single instance uh, resource allocation graph, that is, so R1, this is a box means that there is a process, okay, and round means that is a process, that this is a resource and this is a process, okay, P1 P2 resource R2, okay. So that means, so if like this, so you can see here that for allocation, go to resource and so for so this means that you are requesting, P1 is requesting the item R1, and P1, this means that you are, P1 is requesting the item R2, okay. Are you getting? This arrow means that this resource R1 is allocated to P1, and P1 is asking for, this means that allocated, this means that asking. Are you getting? So this is the case, okay. So because the any resource so this is a resource allocation graph. So there, if there is multiple instance, then it is called the multi instance resource allocation graph, okay. So in this scenario, if there is a cycle, then what happens? Then deadlock is possible but not guaranteed, okay, because if this is a single instance graph, then then this cycle is this cycle helps to detect the deadlock, okay. So there is a thing that, let me see, if for single instance you detect it by seeing that there is a cycle or not, as in this scenario. If there is a multiple instance, then you have to run some safety algorithm like banker's algorithm to check if there is a cycle or not, okay. And how recover it? You are saying about the detection, but what is the recovery process? Resources, processes, preemption, rollback, and processes of kill one or kill all, okay. So I have just shown you about the resource allocation graph. Yeah. Yes, all of the above is true. That if in, I've already shown you that each process is represented by a separate vertex. each resource type is represented by a separate vertex, but there can be multiple instances of resources. Okay, an assignment edge is indicated by an arrow from a resource vertex to a process vertex. Okay, and request edge is an indicated by an arrow from process vertex to a request vertex. So this is the thing. So this is assignment. This is request edge. Okay. So first read this one there. I have written it. What is the recovery process? Okay. Now answer the question. Yes. Anyone else? Yes. All of the above is the correct answer. Yes, Diksha is right. All of the above is the correct answer. Yes, C is the correct answer. Please mute yourself. Hi Nadim, please mute yourself. Yes, this is correct.